We're here to talk about next generation cloud management for Catalyst. And we're going to kind of do something we don't normally do, which is tell you about what's going on under the hood, all the different things that are happening and what we've been working on. My name is Alex Berger. I'm a principal technical marketing engineer in the Meraki business unit. And joining me is...
Hi, my name is Mike Kendall. I'm an engineering manager from the Meraki switching dashboard side. I kicked off a lot of the config for Catalyst Cloud Management.
Thanks, Mike. Steve Ward, distinguished engineer, worked with Alex quite a bit, and I think it's been 2 years since we've been back here when we initially kind of launched this. So good to be back.
Awesome. All right, I'll bring you guys in a second. So, as I mentioned earlier, we're going to do something we don't normally do, break down kind of all the things that are happening under the hood. I know a lot of folks are very familiar with iOS XE and like services that run there, and we're going to talk about kind of how we've been bringing things together and making it far more of a native kind of function. So I'm going to go through a little bit of history, talk about that native management, hand it over to Mike, who's going to talk about all the work we've been doing in the cloud, especially around how we are kind of building tool sets to really interact with switches in a very native fashion. Then I'm going to hand it over to Mr. Orr, who's going to talk about what we're going to be building over the next, I'd say, probably 8 to 12 months. So cloud management, obviously, I work at Meraki, so that's all I work on. But when we first started looking into managing Catalyst, we actually did that with the MS-390. If you're not familiar with the 390, it was essentially a 9300 with a runtime for just being cloud native, allowing us to do the same zero-touch provisioning, but getting us a lot of the hardware benefits and a lot of the really cool stuff that came with 9300s, like NetFlow, adaptive policy, which is TrustSec, a lot of functional things that we've taken advantage of. And the biggest thing that we did with that was ship a box that had a native runtime for cloud. We've expanded that, and you can now buy like the 9300X, L, and M, or 9300, 9300X, 9300L, and a -M, which is that same kind of concept of that out-of-box cloud management. With that portfolio, we've added a ton of new switches, and it's really allowed us to expand the kind of coverage and the architectures that you can deploy and be able to maintain that Catalyst from access to edge, as well as be able to support things like the security group tagging, the flow telemetry, and all of those extended benefits that we get out of that. Now to get into the fun stuff. So this architecture was built very much in a platform-dependent manner. So we had the 9300 and there was the app hosting functionality. So we built an app that ran on the switch, or runs on the switch, I should say, and it does a ton of things. And so we have a lot of communications happening from that application to the cloud. And we've left iOS XE to do what it does well, which is like route packets, switch packets, and perform a lot of security functions. But that application actually does a ton of stuff to talk to dashboard. It's an abstraction layer so that we can push a config and then actually deploy that locally to the box. And if you look at this diagram I built here, from the application to the cloud, it does the heartbeat check-ins. We proxy packet captures. So when you do a PCAP in dashboard, it's very easy. And we do a lot of work behind the scenes to proxy all that packet capture information up to dashboard so you can actually get it in your browser. One of the things that is probably the most intense process on that application is actually taking our kind of cloud native config file, which is kind of shared across a lot of our products. We use the same kind of concepts. It's a key value pair. And then translates that to netconf calls. So we program the box using standard netconf yang. And this can be difficult at times, because when you take a single line and you translate it to hundreds of lines of code, it can be quite intensive, especially time to actually deploy. And so I'm going to talk about how we've really enhanced and optimized, I guess, the processes in this newer architecture I'm going to introduce. This is also how we do firmware upgrades. So that application actually pulls the firmware files down and does the install process locally. So you don't have to go in and load stuff through FTP or SCP or whatever you may use normally. So there's a lot of stuff going on under the hood. Then it does a few other things like local status page. We don't use the web UI in the current generation architecture. We host that in that actual container. Now the cloud talks to that container and pulls information uses protobuf. So we actually pull telemetry and store it in the container, pull it up to the cloud, and that's how we get all the information in the dashboard, especially when you see like clients that are connected, traffic analytics, port up-down status information, any of the logging. And we did a lot of translation in logging too. So we took standard syslog, turned it into a Meraki event log. So it doesn't look the same, but it's using the same kind of data pipeline. And then the last thing really in this portion of it is it also does the local status page. If you make a config change, we take that off the container, sync it to dashboard so that if you make changes locally, it retains it, in dashboard, doesn't overwrite it when the device checks back in. From the application to iOS XE, this is where we do like netconf telemetry subscriptions. So we'll subscribe to a bunch of different endpoints and then find like when there's port up down status changes, all that information. And we also execute some of the packet capture functions using like ER-span. We also have a flow collector that sits there and captures like IPFix flows, translates it into our traffic analytics, and brings that to dashboards so that we can give you like application usage, endpoint, bandwidth utilization, et cetera. And then this is also where the application, writes to the actual iOS XE runtime and is able to, build those configs in. And if you look at features like adaptive policy, where you just turn it on and it's like a single click, we're actually doing hundreds of lines of config that's translated into from that application down to iOS XE, which is how we get a lot of that programming done. And the last thing I wanted to mention here is that we also proxy live tool functions. So like when you ping an endpoint from the switch or you want to bounce a port, we run through and do RPC calls to actually do all of that from that app. Now, we did all this work planning for a specific hardware. And that hardware was that 9300 where we have that app hosting, we have the app hosting interface, and that architecture is very much like very functional in this case, but we wanted to be able to expand. And so we built that in such a platform dependent manner, we had to start looking into ways that we could actually change the architecture so that we could expand to more things. There's also a lot of abstraction layers. So when you think about taking a single line of code and turn it into hundreds of lines of configuration, if you screw anything up in those hundred lines of code, you end up in a state where you've got to debug a lot of different things in a lot of different places, which meant that developing more and more features and bringing in more platforms kind of limited our agility. And we were trying to kind of change architectures on each of the hardware appliances to make them kind of work in the same way. So we decided we'd get rid of the container. Makes a lot of sense, frees up a lot of resources. Also means that we have a lot more of a native connectivity to iOS XE itself. So we took a lot of the logic and the processes and the things that we use for zero-touch provisioning and brought that down into iOS XE. Starting with some services I'll get into in a little bit more detail, like uplink auto configuration. So if you're familiar with unboxing a Meraki switch and plugging it in, it's very easy. It pretty much just gets an address, connects to the cloud, upgrades code, downloads its config, all the good stuff, and you don't have to do anything crazy. We also built in a connect service where we actually execute the secure tunnel connection from iOS XE up to the cloud, and it runs a service we call Next Tunnel, which is a like TLS 443 standard TLS tunnel. The other piece to this is we're still bringing all the rest of the services down into iOS XE, like the config and how we do actual config deployments. So within all Meraki devices, we don't push config. So when a device connects, the device actually reaches out and pulls its configuration down from a storage bucket that we have, and then deploys that config locally. Now that wasn't something that existed in iOS XE historically. You've always had to push config, whether it's through like a netconf call that you're pushing down a giant config file with. And that's really resource intensive. It also means that you've got to have the cloud constantly pushing things down to the switch, or hundreds or thousands of them, which wouldn't scale very well. So we ended up building a config download and upload process to actually kind of negate any of the necessity for the cloud to push a config down. So the switch will actually check in every minute or so and see if it has a new config update. And sometimes the cloud can poke it and tell it does, like, hey, download your config. But it made it a lot easier for us to build a scalable architecture that we could have hundreds of thousands of switches managed with. Some of the other things we moved in is we moved our local status page into that kind of web UI concept using that web server on the switch. We did try to make it look a lot like what you would expect out of a Meraki local status page. You can still make config changes, still see status of connectivity to dashboard, but using a native interface so that when if you wanted to go to an LSP, you could go to an SVI on the switch, you could go on the back panel port and connect in and be able to get into that switch in the same way. The last thing that we changed, and it was a big change, is telemetry. So if you've ever worked with like netconf operations and subscriptions, it's streaming telemetry, which means that it's a lot of bandwidth. It's constant. If the cloud goes away, so does the telemetry, because it doesn't get stored. So we built in telemetry caching with the iOS XE team to actually store it locally, and then we'll pull it on intervals. And this also allows us to scale, but also retain telemetry if like the good WAN goes away. So lots of changes that we've made. We're still interacting with the switches in kind of the same manner where we're pulling telemetry from the box, not pushing telemetry from the box to the cloud. Still kind of interacting with the box using like netconf RPCs to do like port bounces, any of the live tools that we offer, and still providing that packet capture function, which we're going to expand upon quite a bit over the next probably 6 to 8 months. But I want to kind of circle back to, we are not changing the out-of-box experience. So when you get a switch that's running in this architecture, it's going to be the same out-of-box, where you don't have to worry about like pre-staging config on the box and booting it up and making sure it's ready to go. You can still configure everything in dashboard, plug the switch in, and it's going to do all the same things you'd expect. It's going to pull its config, upgrade firmware, and have that kind of really simple process in getting a switch online and connected. And so we've made sure and wanted to ensure that we kept that same experience so that as a customer, as an integrator, you don't have to have 4 different ways of getting hardware online, or however many, but so kept that same experience. Now, when I talk about some of the things that we built in to give that cloud native experience, Uplink Auto Config is a new service that's running on the box, and what it does is it'll actually do the same hunting for a sorry, let me drink a little water here. Not only is it hot, it's dry. So the uplink auto config process will still do the kind of the same concepts of a Meraki switch. It'll hunt for an address. It'll kind of listen and see where there's actually activity on the network, and then try to get an IP address and connect out to the internet. If you statically address the switch for management, it'll still scan and keep a backup list of all the interfaces that could possibly get out, so that if you accidentally like black holed a subnet, it will try to hunt for something else. And if you didn't black hole a subnet, but you accidentally made a config change that screwed up, we have a new safe config rollback. So in all Meraki devices, when you make a config change, we actually mark that config as what we call like config try. It's like the not safe config, where if we lose connectivity, we'll like wait for a little bit. It's not like it happens immediately, but if we lose connectivity to dashboard, we start a countdown timer. And if we haven't regained connectivity after that last change, we will roll back to the previous known good configuration, so that if you have a switch that's sitting 2,000 miles away and you made a change that was very incorrect and it went offline, it'll recover. So we built that in so that if you did make config changes and you manage things at scale and highly distributed, you're not going to have to worry about rolling a truck to recover something.
When it does that,
Yes.
can it present an alert?
Yes.
Here's the difference, and here's what you did.
Yeah. So what it will do in dashboard is if you lose the device, it's obviously going to show offline, and when it comes back, it'll say it rolled back the configuration due to connectivity loss after the last change. I don't know if it does a diff. I know we will tell you about the config changes you've made in our change log, and we store those for like over a year. So you could probably derive it, but I don't know. That's not a bad idea. Maybe say like, hey, you changed the IP and
Here's what you did wrong.
yeah, maybe don't do that again.
Don't do that.
Exactly.
How flexible is uplink auto config for kind of more complicated uplink architectures, whether that's fabric or like a port channel or a routed connection?
Yeah, great question. So right now it's only using SVIs, but we are working on making it very portable so that it could use any layer 3 interface. So if it's a routed interface, trying to think of a good example. Probably not a loopback, just because loopbacks, still have to route through something. So, but we're trying to make sure that it's portable so that if you were, in a highly routed architecture, not just VLANs and L2, that you can use those interfaces as well. So that's planned. Not right now, but that's something that's going to be coming. Any other questions?
I will have. So just to clarify, I understand right. So because you're changing the push and pull direction, so I assume you initiate the tunnel from the inside to the cloud, establish the tunnel, and then the cloud is pulling the telemetry from the switch. Okay.
Yeah, and actually, the reason that we brought Mike here is that he's worked on a ton of this stuff, and he's going to explain it in detail.
Okay, brilliant.
And I have not worked on it. I've just helped. But yeah, no. So absolutely. So we always establish that tunnel outbound, and then we keep a heartbeat going so that we can still communicate with the box. The box can still pull config down and all through a secure channel.
I'll leave the follow-up technical questions.
That's fine. You can ask. I just might not answer.
Yeah. So my question would be probably about the telemetry. How are you doing it? So you've mentioned the net config. So you're not doing any gRPC or anything like that for the real-time telemetry.
All right, we'll hold that one. He's going to answer those.
Okay.
Yeah, those are good questions. Please ask it.
All right. Yeah. Will do.
So with that being said, I'm going to hand it over to Mike.
Okay. So hey, again, I'm Mike Kendall, and I have not signed up for Meet an Engineer. So if you want to talk to me, just talk to me. I'm going to go into three things. I'm going to talk about config mostly because that was my focus, and I'm going to talk about telemetry. I'm going to talk just a tiny bit about event logs. But first, I want to go back to this picture that Alex put up in his slides. What did we ship? We shipped our org chart. So at the top, you can see Meraki Cloud, and it's working exactly like it always has. And at the bottom, we have the device, and it's working exactly the way it always has. And this container that Alex talked about, it's doing all of the translation in between. And when we make that go away, we make this three-way sync problem go away, which has been super expensive for us to maintain. And so the theme that I'm trying to repeat over and over here through config, telemetry, and logging is we're using Meraki methods with Catalyst interfaces, right? So config. Alex mentioned that we're using netconf yang. It looks something like this. There are these big XML blobs, and it's developed directly in Dash. This gives us a few things that we really love, like validating a complete config before we push it to the device. It's something that we can do on non-Catalyst switches that we have a hard time doing today on the 390. It also means that we're going to hook into existing Meraki tooling, which I'm going to go into right after this. It also means that feature development can happen independent of firmware. So if the models for a feature are ready, we can just add that in Meraki dashboard without touching anything on the device. Amazing. Same thing, but the flip side of it, we can fix bugs without touching firmware. So you might have noticed on the MS390, some of your firmware updates were huge and some were kind of small. Those small ones were container updates. And those can now happen without touching firmware at all. Those can happen just in dashboard. So really simple example. We're turning on a port. And to show kind of how the sausage is made, Meraki config is namespace key value pairs. The full config is huge, but the one line that we care about here is port 5. We're enabling it. It's true. The device, when it pulls down the config, it's going to do a diff. And in non-Catalyst switching, we're going to see this diff, and the device is going to change the behavior of the chip directly. But for Catalyst devices, we don't have that level of access. We have to go through Catalyst interfaces. And so if you've worked with Catalyst switches, you know console is what a lot of people use. You go into the particular port, you say no shutdown, and you type end. And when you hit enter on end, this change immediately goes into effect. There's no transactions. There's no safe rollback. It's immediate. Or you can do it via netconf, and you have this huge blob of XML just to turn on a port, and you can't really read it. What I want to highlight is that the container today is doing both of these things. It's doing them in a mix. So today rollbacks are very difficult. You are like saying, oh, I'm doing a console and a netconf and a console, and you have to roll them back in opposite order. And going forward, we are only doing netconf, and that gives us safety in our config that we haven't had before on Catalyst devices. And I also want to call out this big blob has kind of strayed pretty far from where we started, right? We've got a namespace key value pair to begin, and now we have this big blob of XML. And what do we do to reconcile that? Well, if we look at the blob, we zoom in a bit, we see actually there's just one netconf operation here, and it's happening on an XPath. And if we pull out that XPath, oh, what is that? That's a namespace key that looks really, really similar. And so this gives us the power to reuse a bunch of the tooling that has made Meraki config so successful, and just think about config as these namespace key value pairs for Catalyst devices, just like we have in the past for non-Catalyst devices. So long story short, Meraki methods, Catalyst interfaces, and we just have to kind of massage those interfaces. Yeah. And talking about pull-based telemetry. So as Alex mentioned, Catalyst devices have always been pub/sub. Meraki has always been pull-based. How did we solve that? Well, the Catalyst side actually just added caching to telemetry. Now, what are we actually pulling down? Meraki historically has always pulled protobuf, the binary encoded event object. And the Catalyst team has served up their own internal binary telemetry objects to us. And before you ask, why aren't they using protobuf? Because this predates protobuf. It's exactly protobuf, but with a different name, pretty much. And so again, we have Meraki methods with Catalyst interfaces, right? We are using pull-based telemetry. We're doing it over our secure tunnel with some really efficient binary objects, but we found a way to do it in a Catalyst way. I don't have a visual for this, but I want to touch on event log and syslog really, really quick. Again, the Meraki way is to give the event log interface, right, where you can search and you can filter and you can look through your logs. We want to keep that interface, but get to a more standards-based syslog. So the data in your log interface is going to be syslog data, but you're going to use it the same way that you have used event logs in the past. So again, Meraki methods, Catalyst interfaces.
So the syslog data that's ending up there, it's exactly what a Catalyst switch would send to any network management solution?
Yes.
And are you planning on doing any translation to align that with what Meraki delivers?
We're planning on giving some like tooltips, mouse over tooltips to help you out for mapping interface names, for example, but not full on translating to exactly what event logs are for non-Catalyst devices. Yeah.
Yeah, but I had a question about the gRPC. So, like, are you using gRPC for the telemetry? That was my question from the previous.
Right. No, they're cached, and we are pulling them, and it's not based on.
Not pull gRPC. Like
No.
Okay. Why?
Netconf gRPCs just aren't very performant, it turns out.
Okay.
And so, yeah, the Catalyst side has added their own way to pull telemetry. Yeah.
Mm-hmm. Okay.
I'm going to talk about a couple optimizations real quick and then hand it over to Stephen Orr to talk about all the really fun stuff. In our current architecture, we've had variable like boot times. Sometimes it seems like it takes forever. A lot of switches boot really quickly in Meraki, like just regular Meraki MS. And we really wanted to try to see how we can get like boot times down, config deploys like as fast as possible. And so starting at the left side, we've had about a 50% improvement in how rapidly we can get a config update. Like a small update would be like changing some port configs. We'll batch those up and send and put those in that config file so the switch can pull it. When the switch pulls it, instead of being about 30 seconds to execute those operations, we've got it down to about 15 seconds, which means that it's very quick. Like you make a couple changes and usually, under a minute, you're going to have all your configs deployed that you put in there. Now, if you took a switch and factory defaulted it and then had it connect to dashboard, the current architecture does take about 2 minutes to fully deploy because there's a lot of stuff we end up configuring. You think about like getting all of the NetFlow interfaces configured, all of the different port configs that we just kind of consistently put on there. It used to take about 120 seconds, or does in general. We got it down to about 60 seconds. So out of box, get a switch in there. Within about 60 seconds, it's going to have that config deployed with whatever you've put in dashboard. So a huge improvement there. And we're going to continue to iterate and hopefully optimize more and more so that gets down to just a few seconds. But the biggest one is, if you've ever rebooted a switch, it's really painful waiting for it to come back. I've had plenty of flop sweats where I'm like, please come back. Please come back now. How long is
Microcode update? Half an hour.
Yeah. Oh, Lord, yeah. And so a single switch in our current architecture takes about 6 minutes to boot if it's already been onboarded and connected to dashboard. A stack of 8 is variable, but around 11 minutes, which is not a short amount of time. And you talk about, I'm very impatient personally. So when I reboot a stack of switches, I'm like watching, refresh, watch, refresh, pinging, trying to ping interfaces, hoping, it's going to be back quickly. So with this new architecture, since we got the app hosting piece out of the way from a management perspective, we're able to boot at about the same time, whether it's a single switch or 8. And it's about 4 minutes in testing. That may vary as we continue to iterate on things, but much better, much quicker when it comes to rebooting a switch, having it back online, passing traffic. So a lot of really fun improvements there.
So how does it work? Sorry, jumping in. So with the rollbacks we were asking before, so that it takes exactly 60 seconds to fully come up, test the connectivity, and then eventually roll back, or does it do
That's
earlier
the
before
config deploy? So sorry, that'd be the configuration deployment. So once it pulls down the config,
Right.
if it's that entire gigantic blob, if it's already got a config and you're just rolling back part of it, it does a diff and it'll only push the parts that are in that diff.
Right.
So it's doesn't take as much. I would say it's probably more of the small config update when you do a rollback.
So 15 seconds, test the connectivity. If the connectivity is not in there, then it rollbacks.
Well, so what we'll do is we'll actually allow the switch to not be connected for about 30 minutes before rolling it back. The reason why is if you were making changes across the board and you maybe did it out of order and you made the change at the access layer instead of at the core and down or whatever it may be, we don't want to roll back code constantly or firmware, or not firmware, but config constantly, or it would be chaotic.
Can I change it? Can I influence it? So it's going to be less than 30 minutes?
Not today.
Okay.
Not to say that couldn't happen, but not today.
Would these figures be the same for both the cats and the mark?
So the numbers here are completely different when it comes to a MS-130. But the behavior is going to be the same. So the rollback function and all that, that was built so that, if you had 2,000 switches deployed, all over the world, you didn't accidentally, have to send someone out. Sometimes that's painful, most of the time. So we are planning on having empath upgradability. So the code that's on the switches today will have a path to just upgrade into this new architecture. We're not going to make you go wipe all your switches or do some really painful processes to get there. We're going to be automating all of that so that when we go from what we call our CS17 release to our native iOS XE release with 17.15, it should be fairly similar to just doing a code upgrade. And we are in the process of testing right now and making sure that we take care of any corner cases we can find so that it's as easy as possible. Now, one of the things that we are working on is also rollback. So if it upgrades and it can't connect to anything, we probably don't want to leave it there. So making sure that it can fall back and then report in saying the upgrade was not successful, blah, blah, blah. So that's a process we already have today. It's kind of in the same vein as that config rollback, where if you upgrade code and it doesn't, the switch just can't get out for like a good 15, 20 minutes, it'll roll back and then report in and let you know that there was a, installation error or, install error.
Now, when you say in-path upgradability, is that going to be similar to like I'm just speaking generally like the whole Meraki portfolio, right? Like the MS series, MX series, it's like, okay, here's the current version, here's a stable release, here's this one. It's just going to give you one direct path.
Yeah.
Oh, well.
Yeah. The what I wanted to really highlight here is just that if you have switches today in dashboard running our CS17 release or 16 release, or we're going to have a way for you to take those directly from there to this next gen architecture without requiring you do anything wild like be on site and be plugging into stuff. So, yeah.
Then all these architecture changes are going to apply to other managed or observed iOS XE devices like the controllers.
Yes.
Okay.
Well, so controller wise, like don't quote me on that. Well, I am recorded.
Wait a minute now.
There is.
I know they're currently not managed.
Right.
You can just have the observability, but it's still running iOS XE under the hood. So I'm assuming
Yes.
it's all, yeah.
Yeah. So actually, we've been doing a lot of work sharing, processes and functions and behaviors so that it's an easier architecture in general to troubleshoot from an engineering perspective. And so, yeah, we're not trying to build two bespoke, behaviors with iOS XE. That being said, I haven't mentioned monitoring on purpose because we're using the same exact architecture for connecting switches to be monitored in dashboard. Instead of having to run an app, you can just issue a command and the switch will reach out, register itself to dashboard, get you a serial number, and you just claim it, and it's done. Other than that, you'll also have tools to check and see the status of connectivity. So when it's in managed mode, we have all these little bits of details around like last time it fetched config, if it failed to fetch config for some crazy reason. But you'll be able to see like are the tunnels up? Are we sending receiving traffic over the tunnel? And so some debuggability, so you don't just flying blind wondering what's going on. And all of this, as I mentioned earlier, so that we could get to a more platform independent kind of behavior, so that we can get more switches into dashboard. So as we're going through, we're going to be looking at like the 9200s and hopefully soon after that, the 9500s, so that we can get that, full kind of enterprise architecture, that campus architecture, really opening the door for us to do all sorts of cool stuff. That being said, I have somebody here that is going to talk about some of those things.
So Alex kind of covered the what we're doing, and then Mike did the how we're doing it. So I get to talk to you about where we're going. So give you a little bit of roadmap, a little bit of information on what's going on. Now that we have this paradigm shift in architectures for what we're doing with the Meraki dashboard and Catalyst, right? We're going to remove the container off the top of like the MS390 and the 9300s. It's going to give us the ability to put more containers back on. So as Juan kind of alluded to this morning or earlier today, we're going to talk about that Meraki simplification for our operations and actually be able to bring it back and then start deploying out things like Thousand Eyes, containers like Spaces, and eventually bring your own container back onto those boxes with the operational simplicity that Meraki brings to the table. So, Alex touched on what we were doing today with cloud monitoring, being able to have a CLI, what I call a CLI runner, into the box. Where we're going to be able to go is that the lines will blur as we move to native iOS XE being attached to the Meraki dashboard. The lines blur between monitored and managed mode. So we're actually going to give you the ability with a managed switch as well as monitored to be able to do CLI, do some show commands right from within the Meraki dashboard. So I go into the dashboard, I can issue some show commands, and I don't have to telnet into each individual box to pull up CLI. So again, this is where we're going. This is the start, kind of the tip of the iceberg of things that we're going to be able to bring to market for the customers and for the the people that are doing the deployments, so that we get that native attachment. Things become more and more deployable, as well as one of the key things I think that I know Alex and both Mike touched on. The key things here with iOS XE native on the dashboard, the Meraki dashboard becomes an automation orchestration engine for Catalyst features. So we're not developing new features on we're going to continue our Catalyst platform development, but Meraki is going to be configuring the features that are already native in iOS XE. So it allows us more rapid development, more rapid deployment through the Meraki dashboard for features that have been native in iOS XE for a while. So as Alex had also mentioned about, where we're going with bringing new platforms onto the Meraki dashboard. The key things here is one thing that we can kind of alluded to is scaling up and scaling out to those larger customer deployments that we've been poking our head into. So one of the ways to get there is giving ourselves new resiliency capabilities already available in Catalyst, but bringing them in through the Meraki dashboard. So being able to do platform high availability, first hop redundancy, and then in-service upgrades. Again, bring those enterprise capabilities, enterprise features right through the Meraki dashboard through iOS XE. And again, if you all have any questions, please feel free to ask. Another one was routed interfaces were brought up. So again, being able to implement what's currently in iOS XE in through the Meraki dashboard by enabling routed interfaces, giving us all those capabilities to kind of bring that down. Now, what you'll see is as we're building on, software upgrades, we're building on routed interfaces, we're building on all these individual pieces, what we're eventually going to get to and what it's going to bring to the table for us, things like VRF Lite, again, we're not making it from scratch, it already exists. What we're doing is creating the workflows in the Meraki dashboard and then using NetConf and the Yang models to be able to bring that down. So again, another segmentation technology. Alex talked about adaptive policy. So again, this is just extending what we're doing from adaptive policy through VRF Lite and other mechanisms to bring that segmentation to the customer networks. So one of the key things for us too is addressing customer, what I call brownfields, right? So if customers already have these things deployed today, how are we getting them to enable and use the Meraki dashboard as that automation tool if we don't support those? So because they're already in iOS XE, the Meraki dashboard is going to automate and we can bring those customers into the Meraki dashboard to be able to accelerate these features. Now, the other piece, and again, as you see this building, BGP becomes an option as well, because again, it's native today in iOS XE. So we're going to be able to integrate the BGP function with what we're doing in the MX today, and also other architectures that we'll talk about in a second on what's going to be able to take advantage of us doing both eBGP and iBGP throughout the Catalyst infrastructure. Questions? No? Good? All right. So what does that bring to the table at the end of the day? So as I was showing you what we're building through, this goes to the Meraki dashboard, automating an EVPN fabric on our Catalyst hardware. So we're going to be able to bring this end-to-end through the customer architecture. Now, when I say bringing EVPN, this is the same EVPN that exists today inside iOS XE. Again, we're doing operational simplification through the dashboard, and we're going to kind of use the easy button for being able to bring these fabrics to market, right? So this is we're targeting those customers that want to bring this in using adaptive policy, right, at the edge, bringing it in, mapping it to these EVPN VXLANs, and then bringing an end-to-end segmentation model. So again, this is all as we go from the how and the where, this is how we're going to get it out to the customers as quickly as possible. So with that, and I know we've got some time because we want to leave some time open for some questions. As I said, really one of the key things to kind of take away from the discussion we had today, and actually even the discussion we kind of brought in 2 years ago when we initially introduced this, the whole goal of this project is really just using that dashboard as the mechanism in the vehicle to automate, orchestrate, and actually do the assurance piece for Catalyst hardware and accelerate those features, accelerate the adoption of things that are already in the network. We've already got, we've been talking about what else can we bring to market. We have access now directly without the container to all the features that are in the dashboard or in iOS XE. We just need to figure out and prioritize with the information we're pulling on what features customers need and want and how we get them to market for them. So with that, what I'll do is I'll pause. I know we've got Alex and Mike. Any questions?
So I've got kind of a product positioning.
Sure, go ahead.
The orchestration, the zero-touch provisioning, some of the centralized security policies, features, these are all Catalyst Center functions.
Yeah.
Where do you see a customer that is going to use Catalyst Center versus this kind of monitored and managed within Meraki?
Awesome question. So we have a couple different customer sets, a couple different customer use cases, right? Where we see Catalyst Center having a large deployment today is in because I used to come out of the federal space, so air gap customers. Customers need on-prem like pharma and other things that may have, can't do cloud direct connectivity. So we see them doing that. And then also bringing in SDA and all the other technologies that they have. This is for those customers that have a cloud first initiative. We're starting to see a lot of customers come in with cloud first initiatives. They want a SaaS model. So this is where we're being able to bring them in through the Meraki dashboard to kind of bring those features in and get them
Do you see a customer set actually migrating from Catalyst Center up to the Meraki dashboard?
So I've actually seen, and we've worked on I'll call them hybrid deployments, where customers will do branches, like they've had Meraki in the branches forever, and then they've got Catalyst Center, or formerly DNAC, in their large campus sites. And what we're working on is having them, with that journey to the cloud, migrating over into the Meraki dashboard, or even bringing the telemetry into the Meraki dashboard as well. So same thing with wireless controllers. We have a lot of customers that have Catalyst 9800s that may not be using Catalyst Center, or Prime has gone end of sale. So what they're doing is they're actually just migrating the 9800s to start and bring them over to the Meraki dashboard. And do you have any? You're just.
I just wanted to come stand.
That does lead to a question. You mentioned the 9800s.
Yeah.
So everything we talked about so far is Catalyst switching. Now we're talking Catalyst wireless. How far is the whole Catalyst integration going to go?
So the plan is to integrate the Catalyst portfolio. So I know we're doing a wireless session a little bit later today, so I won't steal the 9800 folks' thunder. But what we're doing with the 9800 to start is the 9800 will be in monitor mode and access points. I think we're going back to the 3800 series access points.
Yeah, for monitoring, yes.
For monitoring. So we can take the whole, not just the controller, but the controller plus the access points, and we'll monitor them in the Meraki dashboard. So we kind of we'll give a single pane of glass. So if you have a mix of Meraki and Catalyst gear, we'll give you that single pane of assurance glass.
So it's kind of going to follow the similar, well, different, but similar rollout to when Catalyst moved over. We should start with monitoring mode and then monitoring, onboarding, and cold.
Yeah, so there'll be more capabilities that go to the 9800 through monitor mode, but then there's also, and again, I don't want to steal anybody's thunder, for the wireless team, we'll talk about it a little bit later, but there's also a tunnel concentrator coming out on the.
Yes.
Look forward to the details as they come.
Yeah, speaking to you asked about the software architecture, like the wireless controller monitoring is using that same, like the same connect concepts, the same like tunneling, all that. So we shared that kind of code across the board so that it was kind of the same runtime, same function.
It's all very neat. I mean, are there any plans in the future for there to be like a single clutch rather than the cat and the dash full integration, cat Meraki full integration?
I'm sorry,
Like a single switch in the future rather than the separate product trains?
So kind of homologating kind of the product strategy and the roadmap.
I mean, we do intend on consistently like ensuring we have coverage for Catalyst and being able to buy Catalyst in a cloud native like runtime. But we do still have a significant part of the market that is looking for lower cost, like the 100 series, where that's why we have like the 130 right now. We came out with that because it does hit a specific like part of the market that may not have the desire to buy a very expensive small switch and want something a little bit smaller but still functional. So only when it's necessary, not just out of spite, to have two different portfolios to make you have to choose.
And if you kind of listen to the long term, like what Juan was referring to, like Cisco Network and Cloud, the whole goal is to kind of bring our software and hardware platforms to a more consolidated space so that we don't have significant overlap between campus switching products, wireless products, and WAN edge products, as well as management consoles, right? So if you listen to JD, his kind of mantra is we're going to try to get down to a cloud management platform and an on-prem platform for management.
So you're enabling features right now within the iOS XE platform. Are any of those features that you're enabling on iOS XE moving over to the Meraki switch lines as well, or are those going to be kind of separate and hardware locked?
Great question. So one of the ones that we focused on and are getting ready to launch beta is adaptive policy. So microsegmentation on like our 130s, like the X and R models. That's I would say like a solution that we know needs to be kind of fairly ubiquitous for it to be useful. And so not like specific features per se, but like solutions and trying to ensure that we, have good coverage across the board. So if a customer buys, 9300s at their access layer, but they have compact switch needs and they've bought 130s, we want to be able to support a lot of those kind of extended use cases and functionalities. So
yeah, that's kind of my concern when we start talking about enabling advanced features on Catalyst, but then having some Meraki in there and you've got a dashboard that you've configured everything on, and then you're either you have to buy everything on the high end stuff, or you're running into areas where you can't use that feature across the board.
Yeah. That's what I love too about it. For like years, it's that you've been able take it. The way it sounds, you'll be able to take whether it's small or a home office or like a smaller branch or a larger thing. Everything's just going to be integrated into one and has support the same features.
Yeah, I mean there are going to be some features we will take advantage of and put into the Catalyst switches that we might not be able to support, but our typical goal is to make sure that if we have a feature that's like software based, being able to try to carry it across the portfolio where it makes sense. There's some things that are more difficult than others, and so it's really about like what's going to be the most advantageous for the customer. Especially when customers ask, it's like usually what we try to roll into our development and roadmap, I guess, essentially.
And
Yeah,
one
so
of the
it's
things we're trying to focus on use cases versus individual kind of feature-based prioritization. So like if you look at kind of what we just talked about on where we're going for the next couple of months, all those individual features are building up to us being able to deploy a fabric through the Meraki dashboard, right? So the use case, the end goal use case is bringing those brownfield customers on and then getting them to be able to deploy a fabric as the end outcome.
If I may, so just to make sure like I understand, so like moving the clients from the Catalyst Center to the Catalyst Cloud, and let's say I'm running the SDA with the Catalyst Center, moving them on the Catalyst Cloud. So I'm going to be basically moving them with the SDA capabilities. Like, am I moving the whole fabric on the cloud management, or there isn't the parity yet? Or are they, and if not, are there intentions to sort of like move that parity? So I'm going to be able to manage my SDA with the cloud.
It's a really good question. So right now we're working on trying to make sure that we can deliver, a very very capable but simple kind of fabric deployment. So like not a ton of config things that you have to do. That's not to say that in the future we don't have like migratability or we don't expand like support, but right now we're trying to make sure that what we offer is like those cloud native customers that are, or like customers that are focused on cloud native to have something they can use that gives you that mobility. I mean, that's our main focus for Fabric is mobility. We have the security part taken care of, with the adaptive policy and like trust sec functions. And so it's really just about building that mobility piece. That's not to say that down the road, though, there's not an opportunity for us to figure ways to do,
Yeah, because I've seen some parts like mentioning EVPN, but I haven't seen, for instance, you've been mentioning SGT. So that's why I was sort of assuming like it's not probably like complete replica of SDA what you're trying to do in here.
We're also, we're kind of following where we're going with Catalyst Center right now. So Catalyst Center's looking at automating EVPN. So we're looking at the common ground right now between what we can do to bring EVPN and then see where it goes from there. So again, with Catalyst Center, we've got the ability to move that into AWS and give it more of a IaaS type service where we're bringing it and taking and putting the VMs in the cloud and giving them that option so that they don't have to migrate to something else. And it gives them that flexibility on where to deploy. So it's not a one or the other. I think it's a, depending upon the customer deployment, customer scenarios, we can stick with Catalyst Center on-prem or in a cloud, in a private cloud. And then we can migrate on the Meraki dashboard for those hybrid environments.
Okay.